Hello everyone, welcome to this video. In this video we are going to see another basics, which is the complex numbers. So if you remember, what are complex numbers? Complex numbers, they are expressions of this form where we have a plus b multiplied with square root of -1. So wherever in our quantities we have to deal with square root of negative quantities, so we call those number as complex numbers, right? Here this a and b, they has to be real numbers, right? So this is the definition, and if you remember that we every time write this square root of -1 as the term iota, so that when you square both sides, so what is iota? Iota is square root of -1. So if you take the square on both sides, so this quantity is equal to -1, so you have iota square as equal to -1, right? This is one thing. Another thing is that you can write complex numbers in this form a plus iota b by replacing this square root of -1 with iota. So this form is known as the standard form, right? And moreover, sometimes it is very convenient to write complex number a plus iota b as some point ab in the plane, which is constructed by a horizontal real axis. So you can see here we have this horizontal axis as the real axis and a vertical complex axis, and this axis, that is a imaginary or a complex axis. So here, so this represent all the coefficients for b, all the coordinates for b, and this represents all the coordinates for a, the first quantity, right? So we can represent the number a plus iota b as some point here by a comma b, right? This is the graphical representation of complex number. And moreover, the distance from the point a plus iota b to the origin, this is the point which is the origin. So this distance, this is known as r, and it is calculated by taking the square root of a square plus b square, and sometimes we represent it as the modulus, this two straight lines modulus of the given complex number, right? And moreover, this line, whatever angle it makes with this real axis, we call that to be theta, right? So theta is the angle which is formed between the line segment representing the given complex number and the real axis. If that is so, and if this length is equal to r, then we have two terms, one is r, another is theta. So we can represent our complex number in this form also. So it becomes a plus iota b is equal to r times of cos theta plus iota sin theta. So this form is known as the polar form of a complex number, right? So this is about complex numbers. Now next, let us discuss few properties of complex numbers. The first property here is closure under addition. So how do you add two complex numbers? Suppose you are given the first complex number as a plus iota b, second one is c plus iota d, then how do you add them? You just add the real portions of them. This is the real portion, so you add a plus c, and then separately you add the imaginary portions, which is b and d. So this is how you add, and after adding them, is a plus c again a real number? Because we know for a given complex number a plus iota b, a has to be real number and b has to be a real number. So after adding a plus c, is it a real number? Yes, it is a real number. So this is a real number, and moreover b plus d is also a real number. So it satisfies the condition that both the real and imaginary part has to be real. The coefficients here, they has to be real. So this is real, and that is what we mean by closure. Closure means if you take the one kind of elements, and after performing this addition or multiplication or whatever, you again have the same kind of elements. So you started with complex numbers, again you end up at complex numbers. So this is the property of closure, right? So after this property, let's see the property of closure under multiplication. So that means when you multiply, the first thing is how do you multiply, second thing is after multiplication, is it a complex number? So we have to answer these questions. So let's first answer the question how to do the multiplication. So you have two numbers, a plus iota b and c plus iota d. So how do you multiply? You multiply term wise. So you multiply a with c, you multiply a with iota d, right? So you have the first two terms. Then you multiply iota b with c, the third term. Then you multiply iota b with iota d. So you have this last term. And you know what is iota square? That is equal to minus 1. So this term is equal to minus bd. So what you do? You club up all the real terms. So which are the real terms here? The real term is this ac and this minus bd. So you club them together and then you club all the iota terms which are ad and bc. So this is what you have after calculation, AC minus BD plus iota AD plus BC. Now AC minus BD, is it a real number? Yes, it is a real number. And AD plus BC, is it a real number? Yes, it is a real number. So you have something of this from x plus iota y, where both x and y, they are real numbers. So that means this is a complex number. So therefore we have the property of closure here. So that means you have initially started with multiplying two complex numbers and now reach again at a complex number, right? So this is the property of closure. Next, let us discuss the property of division. So first of all, let's answer how do we divide two complex numbers, and then we'll see whether after division do we again end up at a complex number. If so, we have the closure property under division also. So for division, you know the denominator should not be equal to 0. So we are taking two complex number, one is a plus iota b, another one is c plus iota d, and we are taking c plus iota d as not equal to 0. So how do you divide? In the denominator, we wanted to make this element as a real number and we wanted to get rid of this iota in the denominator. So what we do, we take the same number, but now here in place of iota we are taking minus iota, right? So basically we are taking the conjugate of this number. So when you multiply c plus iota d with c minus iota d, what are you going to get? You are going to get c square plus d square. You could perform this calculation according to this second property here. So you see you are going to get c square plus d square, which is a real number. So that is how we are going to get a real number in the denominator, and for that purpose, because you are multiplying by c minus iota d in the denominator, you have again to multiply c minus iota d in the numerator as well. So after multiplying the entries in the numerator, you are getting this term. So you could separate out the terms. The first term would be ac plus bd divided by c square plus d square, and the second one is plus iota times this bc minus ad divided by c square plus d square. So you see this is some calculation plus addition, multiplication and division of some real numbers, which is again a real number. So this is a real number, right? This belongs to the set of real numbers, and again this is a real number. So obviously here in this case, after performing the division, we are again getting a complex number. It is of this again form, x plus iota y form, where both x and y, they are real numbers, right? So therefore we have the property of closure under division as well, and now you pretty well know how to perform the division. Next property is about complex conjugation. What does it mean? It means that you just have to multiply the same number by replacing iota with minus iota. So a number in which you have the same entries except iota is replaced with minus iota, that is known as the complex conjugate of the given complex number. So once you multiply a number by its complex conjugate, you will get a square plus b square. This is the property. You can check it under the using the formula of multiplication here. If you apply this thing to these numbers, you will get a square plus b square only, right?